All right, so we're going to begin today, chapter 7, talking about confidence intervals. So, here in chapter 7, section 1, we're going to do an introduction to what confidence intervals are, and we're going to talk about CIs for mu when sigma is known. So here we're going to be trying to come up with a confidence interval for the mean, and the assumption that we're going to be making is that we know the population standard deviation. That's what sigma is. So let's go over a couple of basic things. A point estimate is one specific value that is going to be, like it says, an estimate of a particular parameter for a population. So remember, a parameter is a measurement of some sort for that particular population. All right, so basically, we want our point estimate to have various different qualities, but basically in the past we've said, okay, chi bar, and that's what we have this. Have And so we say, okay, well, mu is roughly going to be what chi bar is equal to, right? So, I mean, that is basically what a point estimate is. So we have one single value, and we say, yeah, that's that's it. There you are. There you have it. Nothing more, nothing less. So now, what we are going to want to consider instead, the reason that we're going to be talking about confidence intervals, is an interval estimate. Okay, so basically, an interval estimate, you can kind of think of this as a point estimate with a margin of error. So a lot of the time you'll see a poll, for instance, that says 55% favor candidate X. Um, and that's what people focus on, the point estimate. They say that one specific number, that's it, 55%. Okay. Um, and then for various different polls, you may notice that if they're being genuine, they'll tell you what the margin of error is. They'll say it's 55% plus or minus 3%. So that means what we actually have is a broader range for the estimate. It's not one specific number, it's a whole range of different values that we have basically a greater likelihood of the true parameter, the exact value, if you will, falling into that interval rather than just being fairly close to this one. So an interval estimate is essentially saying like a range of values. So for instance, as an example of this, we might say, okay, look, from 21.9 all the way to 22.7. That's the range that mu could be in. And that gives us a little bit more leeway or a little bit more freedom rather than just saying something kind of silly like mu is exactly equal to 22.3. Boom, there it is. Oh, sorry, you can't see that. So the idea of creating an interval estimate such as this, right, versus what we've been looking at in the past, essentially. Point estimate is just one single value. So here it's kind of like the difference between saying, okay, well, look, here the candidate X just has 55%, and if we just gave that would be analogous to what we were saying, you know. But then if you say plus or minus, in this case, it is 0.4. Right? If you pay attention to that part, the margin of error, that gives us a range in which we're predicting that the actual proportion of people who favor candidate X, well, I'm sorry, we'll talk about proportions later on. Right now, we're going to be focusing on mu, the mean. And again, this is kind of like an introduction. This is a practice, essentially. And so the assumption that we're going to be making is that we have sigma, right? Where in reality, if you're out in, doing research, if you just have a sample, with which to estimate the parameter, right? So we have chi-bar to get a rough sense of what mu is. If we don't have the population parameter mu, then we probably don't actually have sigma. So this first section in chapter 7 is essentially just for practice. Yes, we will be, assigning problems out of this. Yes, I will be quizzing you on how do you do the mechanics of, the basic z-test for a mean. But just for basically our usefulness, the utility of this is not very much. We're going to be finding the next section to be what the real world situation is actually going to be closer to. All right, so let's move on to what we mean by the confidence interval. All right, so let's turn the page here. Okay. All right, so we'll talk about two things. There's the confidence level is the first thing that we'll set. Sorry, I mean to keep moving my page around or moving my face around, but the computer cord is fighting with me. So, all apologies. The confidence level is what we'll talk about first. So this is usually going to be given to us. Given, if it's not given, then we'll assume it to be 95%. I think that is the standard assumption. Until I say otherwise, we'll just assume that our confidence level is 95%. Or they will give it to us. They will say, come up with the 90% confidence interval or the 99% confidence interval. Or sometimes they may even tell you, oh, give me the 95% confidence interval. But this is going to be a common confidence level that we're coming up with. So basically, here the confidence level is the probability that our confidence interval that we create will actually contain the mean. So essentially saying our margin of error is going to contain, is actually going to incorporate what the true value is, all right? And it's called a margin of error because there's a slight chance that we could get it wrong. So if we're setting our confidence level at 95%, yeah, that means we're pretty surely going to get it, but there is that 5% chance that our true average may not be close enough to our value that we're getting from our sample. All right, so basically that's what we're talking about when we're setting the confidence level. Somebody either comes and sets that for us, or we set it for ourselves. And most of the time we'll say, if we're setting it for ourselves, we'll say it's 95%. All right. Now, what is the confidence interval? This is the interval estimate that is going to be centered around the mean in this particular case, and it is going to be going through the actual x values themselves. So the confidence interval, I'll give us the formula really quickly. I actually like to do it like this. I like to break it down so that we look at the margin of error, and say E for margin of error, and that is going to be defined as our critical z subscript alpha over 2 times sigma divided by the square root of n. Okay, so that's the first thing that we'll do. So I'll call this the margin of error, because the book doesn't really break it down like this. They give you the whole formula just sort of all at once. And in this particular regard, I like to break this up into a couple of more bite-sized pieces. So the first thing that we'll do is we'll compute our margin of error, and then we already have the statistic for our sample, right? For our sample, we've computed the mean already. We should be able to compute a mean. And so I'll say this, because it's just easier for me to remember it like this. Mu equals, and then I'll say chi bar plus or minus E. Okay? So that's, for me, that's analogous to saying, okay, you're 55% plus or minus 3%. What the book will show you, and this is correct. Okay, so it's gonna go from chi bar minus what's E. Okay, so it's z subscript alpha over 2 times sigma divided by the square root of n, and that's going to be the lower bound for what our population mean could be. And then on the other side we have chi bar plus the margin of error, so that's going to be the upper bound is whatever the average from our sample was plus whatever the margin of error is going to be. So that is, again, we'll just write it out, z subscript alpha over 2 times sigma divided by the square root of n. Okay. In the description, hopefully I should remember to post a link to the video about alpha, 1 minus alpha confidence levels, and creating a 1 minus alpha confidence interval. So here for confidence level, we'll say 1 minus alpha, and we'll talk about that later. Okay, and in a different example, we'll do, in a different video, we'll do an example. In a different example, we'll do a video. No, in a different video, we'll do an example. All right, so we'll stop here.